Chapter 6, Section 2. Ratios and proportions. Now, when it comes to ratios is very, very important because we will be seeing ratios again when we focus on probability. And we'll be using that when it comes to odds. We're not there yet, but that will be in the middle of the semester. Ratios itself is pretty simple to understand, as well as proportions. What is a ratio? A ratio is a comparison of two quantities using division, comparing quantity A with quantity B. When we have ratios, we want to try to make sure that our comparison has the same units of measurement. If the units are different, we must convert our units so they can be the same using some sort of conversion. Sometimes you cannot convert one into another. That may need a different approach. But when it comes to setting up a ratio, for the most part, at least for the beginning, we want to make sure the units are the same or see if we can convert the same. For two non-zero numbers, A and B, the ratio of A to B is written as A to B using the colons. Or you can write as a fraction, A over B, because once again, it's comparison of two quantities using division. And division is also in the form of a fraction. And we're going to see how to set up simple ratios when we answer questions 1 and question 2. Look at the first one. According to the Sporting Goods Manufacturers Association, 95 million Americans participate in recreational swimming, 56 million Americans participate in recreational biking, 52 million Americans participate in bowling, and 44 million Americans participate in freshwater fishing. Find each. The ratio of recreational swimmers to recreational bikers. I'm going to first set my ratio up in its fraction form. And I'm going to have recreational swimmers be my A and my recreational bikers be my B. When I set that ratio up in its fraction form, that is going to be 95 million. Had a brain fart right there. Over 56 million. If you notice, the units are the same, which means they can simplify each other out. And when they simplify each other out, I'm left with 95 over 56. We can also write that using the colons, 95 to 56. Or we can write the ratio using the word to, 95 to 56. These answers, no matter which form it is in, is the correct answer. Remember, a ratio is also a fraction. So if you can simplify this fraction in any way, you should simplify. When it comes to Alex, it may accept a non-simplified answer. But when it comes to a mathematics exam, especially if it's in person, then you have to have a simplified answer, especially if it's multiple choice. Let's do B. The ratio of people who fish to people who bowl. It says we have 44 million Americans that does freshwater swimming. So 44 million to 52 million who bowl. The units are the same, so they can simplify each other out, which leaves us with 44 over 52. This is a fraction, which means we must simplify this fraction to put it in simplest form. We must find the greatest common factor between 44 and 52. And this is how you find your greatest common factor. You want to list out the factors of each number, 44 and 52. And you want to find the largest factor that they both have. Here are numbers that we use when we multiply to 44. 1, 2, 4, 11, 22, and 44. 1 times 44, 2 times 22, 4 times 11 is 44. When it comes to 52, 1, 2, 4, 13, 26, and 52. 1 times 52, 2 times 26, 4 times 13. They all give us 52. Looking at both lists, both has the highest common factor as of 4. They both share 1 and they both share 2. Choose the largest number, which means we're going to divide that 4 from our numerator and divide that 4 also from our denominator. 44 divided by 4 is 11. 52 divided by 4 is 13. This is my ratio in simplest form. 11 to 13. We can write that using the colons. And we can use that using writing the word 2. All right, guys. Hope number 1 made sense. Hope you guys enjoyed it. Make sure you have this down because I'm going to transition into question number 2. Number 2 will stay with ratios as well. But remember what I said before. Having the same units is important, especially when you're simplifying the ratio. Now, look what it says here. Suppose that we want to compare the lengths of a 2-foot board and one that is 18 inches long. Write the ratio that provides an accurate comparison. So we have a 2-foot board compared to one that is 18 inches. If you look here, the units are not the same. The first one's in feet, while the second value is in inches. However, we can convert from feet to inches because remember, in 1 foot, there are 12 inches. If 1 foot is 12 inches, then 2 feet is 24 inches. I can convert my 2 feet into 24 inches. And that's exactly what I will do. 24 inches. Let's rewrite that. Now, both has the same units of measurement, so they can simplify each other out. So we have 24 over 18. And we want to find the greatest common factor. Moving forward, I will not list out the common factors like I did for 1B, but I'm going to do it again for number 2. So we have 24 and we have 18. Numbers that we multiply to get 24 is going to be 1, 2, 3, 4, 6, 8, 12, and 24. 1 times 24, 2 times 12, 3 times 8, 4 times 6. Numbers we multiply to get 18, 1, 2, 3, 6, 9, and 18. 1 times 18, 2 times 9, 3 times 6. Both lists has the numbers 1, 2, 3, and 6 in common. The greatest common factor will be 6. Which means I'm going to divide 6 from the numerator and denominator. 4 divided by 3. So the ratio can also be written as 4 to 3, or using the word 2. All right, guys, that is it when it comes to writing ratios, how to write them. We will need to use this again also when we look at the applications of proportions. And proportions also use ratios. So chapter 6, section 2 is fairly an easy part to get through if you understand what you're doing. I zoomed all the way out if you fancy a screenshot. I'll see you in the next video. Take care.